Have you ever pondered over how we can find an angle from its trigonometric ratio? It's a question that can be answered with the help of inverse trigonometric functions. There are 6 main inverse trigonometric functions, each corresponding to one of the principal trigonometric functions. These include, firstly, arcsine, notated as sin 1a. This is the inverse of the sine a function, and it gives us the angle whose sine is x. Secondly, we have arccosine or cos 1x. This is the inverse of the cosine function, and it returns the angle whose cosine is x. Next, there's arctangent, represented as tan 1x. This function inverses the tangent function, yielding the angle whose tangent is x. The fourth one is arccotangent or cot 1x. This is the inverse of the cotangent function, and it gives us the angle whose cotangent is x. Then we have arcsecant, denoted as cc1x. This is the inverse of the secant function, and it returns the angle whose secant is x. Lastly, there's arcosecant, represented as csc1x. This function is the inverse of the cosecant function, and it provides the angle whose cosecant is x. Remember, these inverse trigonometric functions are generally represented using the arc prefix, for instance, arcsin x for the inverse sine function, arccos x for the inverse cosine function, and so on. The domains and ranges of these functions are specific. For example, the domain for arcsin x is between -1 and 1, and the range is between p2 and p2. These ranges and domains are essential for understanding the behavior of these functions. The graphs of these inverse trigonometric functions are generally U-shaped, but the specifics depend on the function and its domain. Now you might wonder, where do we use these functions? They have a wide range of applications in various fields. For instance, they are used for determining angles in right triangles, solving trigonometric equations, mapping coordinates in polar coordinates to Cartesian coordinates, analyzing motion in circular motion, designing electronic circuits, and even calibrating scientific instruments. In conclusion, inverse trigonometric functions are a powerful tool in mathematics and beyond. They allow us to determine angles from trigonometric ratios, opening up a plethora of possibilities in various fields of study. Armed with this knowledge, the world of trigonometry becomes a little less intimidating and a lot more fascinating.